Nobody volunteered.
Thank you.
Jeffers good, but we need physical stride though. Yes, it is.
You can use Etherpad and you like that. Okay, did we get anyone?
No, we did not.
How quickly is the MEDEC go up and going?
Just about to sign the text to see if it's there. I have not been running the screen version.
Pardon?
I'm about to sign in the chat version of it.
Okay. How close are we? Where should we be starting now?
We are 2 minutes in.
Okay.
Actually, 1 minute in.
Okay, I guess I can start. The clicker's here, and I have to plug it into the... Nope, that's not what we look for. There it is.
You're mostly sticking to topology and other stuff this session, right?
Pardon?
This session is almost all topology.
Topology, security, this IPC stuff.
Okay, so for about half of that, can you describe a last resort?
Yes, I'm looking for the... It should be a dongle here someplace.
Yeah, the dongle will actually insert in the back end, I think, right?
Oh, that's what I'm looking for. Yep. Okay, I've had trouble with these ports not having... Okay. Okay. Does it go down? Yes. Okay. Good afternoon. This is our last session before the social, so we'll try to be prompt and get you out on time to enjoy either the social or some fun in Prague. This is the note well. Please note, take your time. The slides are online. Please read it. This is an IETF session, and we operate under the note well constraints. Our agenda for today is the TEAS topology report. Pravana, are you in the room? Okay, I can give that instead. We graciously had a good discussion with the TEAS working group. We're going to give a quick topology model update. Sam is going to give us a discussion of IPSC. I'm going to go through protocol security. And then Daniel, is Daniel here? Daniel has R2S environmental security. Now, environmental security is specific for the people who are in NetConf, not a NetConf protocol issue. It is simply the security environment. One of the feedback pieces we got on the architecture is we didn't necessarily consider the environment that R2S is working in, and that it might be different, and we needed to consider these things for the security people to be able to evaluate the IR2S protocol. So I thank Daniel for working on this, but I want to make sure that the people who are interested in the requirements for NetConf know this is not for them. Okay? We will go quickly through the slide set. Alexander, why don't you come up and be ready, because I will be that quick. So I'm going to use one of Alexander's slides in that you notice that in his generic model we have service, we could have L3, we could have L2, and the question we had with the TEAS group is, what about the TEAS topology, which is at the same level? That in the TEAS topology we actually had all three levels as well, from L0 to L1 to L2. So we met with the TEAS, key members of the TEAS working group in a session last night. They were kind enough to meet with us after all the other sessions at 8 o'clock at night. And we looked at the generic topology model, and what we agreed is that the TE topology will augment the generic network topology as a full stack. It will augment the general topology model, and that in the L3 topology, the TE topology doesn't have to be congruent with the routing topology. You may have a TE topology which is in a different set of topologies. To cater to where the congruency does exist, the topology elements in the L3 topology will reference corresponding. That way, if you pull a full topology model, you can see where it's corresponding and where it's different. The same thing will happen at L2, and it will reference it. That way you can know your whole topology model for layer 0 through service layer in the generic way, and you can know the full topology database in TE, and you will know where they intersect. I think that will give us great information about the network for the programming interface. And again, the L1 topology, the TE topology is an abstract of the data plane. And what will happen is the L1 and L2 topologies there will augment. Fortunately, Xian, who has been doing all the I2RS modeling, is well aware of all of this, and the co-authors between the two working groups will work well together. So we sort of have for free the TE work. So that's our result of the meeting. Is there any question on this? Please come to the back mic. Jeff tells me that the front mic is not working. Alexander, it is your turn for the update. Do you want the clicker? Yeah. Or I can click it for you.
No, fine. I just needed one.
Okay. Mike is over there.
Okay, so just to really, this is
the pink box is where the people on the camera can see.
The pink box on the floor? That way the Meet Echo will see,
okay.
We'll see your charming posture.
Okay.
Thank you.
Okay, so my update is also really short. So yes, there are two models, two drafts, and basically one for the generic network topology model, the other for the layer 3 network topology model. And basically new versions of the drafts have been posted since the last time. Basically, they are also now working group drafts. The updates are actually very minor. In the generic model, there are just some very small editorial updates. The model itself is essentially unchanged. Regarding the layer 3 topology model, there are also a few more, but still minor editorial updates. There are some slight changes to the model simply to reflect early updates in the generic network topology model from an earlier version that had not been tracked yet, which basically needed to make sure that basically we have the augmentation and the condition and so forth expressed correctly. And also that's the other change, also in relationship to the T's discussion and so forth. Basically all the TE references have been removed, so this is now handled completely separately in the T's draft. So this basically just shows again the high level data model architecture. There's a little bit augmented over the diagram that is in the draft itself. So we have basically the abstract network and abstract topology model, with then basically the layer 1, layer 2, layer 3 topology models and their respective drafts derived from them, the service topology model as well, and also basically the TE topology model. So this is basically, as Sue showed on the earlier slide, this basically depicts this graphical. And that's all I have.
G, questions for Alexander? Okay, we'll go on to layer 2. These are quick. Oh, please go ahead.
Okay. I have a comment on the generic network topology model. The comment is, at the moment, the generic network topology model does not have notification, but I checked layer 3 and layer 2 as well as TE topology model. They have notifications of similar kind. So I wonder it makes sense to write a generic, put the notification in a generic network model. Yeah, that's it.
Yeah, I think that's a good suggestion, actually. I think it's something that we should consider, so also for the discussion. Yeah.
Thank you, Xian. Any other questions? Okay, we'll go on to layer 2.
Okay, brief update of the layer 2 topology YANG model. It was adopted as a working group document, and support for the legacy layer 2 technologies has been added to version 01. Also, we added a notification in this version. So this is all updated in this new version, and we would like to solicit more reviews to improve this model and draft, and welcome to making contributions to this work. Thank you.
Any questions for G? Okay, we will go to layer 1. Xian, it's your turn.
Hi everyone, my name is Xian from Huawei. I'm presenting the layer 1 topology data model. So actually I'm just recapping what Sue just said in a bit more detail. First is that, as some of you have noticed, there's not an update on the layer 1 topology model, but I'm actually have a local copy. I've augmented the generic network topology model as Alex showed. And I narrowed down the scope to the ODU layer, which is the TDM switching layer. As for the layer 0, which is the lambda switching, it will be covered in separate drafts. So as we discussed on Monday night, that the ultimate goal for the layer 1 topology is going to augment from TE. But at the moment, there are issues I need to work out with the TE topology draft authors. And also, as like Alexander already mentioned, that the TE is going to augment from generic. So I need to make but that happen before I can actually augment from the TE topology. I personally think that the I2RS making the enable the capability to manipulate the topology. So that's why I put the layer 1 topology model here. But in terms of the people who knows layer 1, layer 0, it belongs to CCamp. So we agree that CCamp is the better place for this work. So in the next version, I expect that we will move it to that working group. That's pretty much it. Thank you.
Do we have a CCamp chair here?
Maybe not.
Do we have a CCamp chair in the house? Okay. We're hoping, we haven't confirmed, we think the CCamp chairs will be happy to take this, but I haven't confirmed that.
Actually, Daniele, one of the CCamp chairs, he asked me offline. I think he's happy to take the work.
Oh, good. We've got a confirmation then. I love it when someone else, Shanna's done really good to organize that. Are there any questions about this? Okay, I think we're done with that. Thank you. You all may get to have an easier time. I'm going to go to the draft that I've been holding. First of all, it's the service topology. One thing when we discussed last, was there a question first before we go? Oh, you're the mic fixing. Okay. So the service topology is one of those things. I'll go stand up. Okay.
Or you could take the clicker.
So I'll stand in front of the mic as well. So as the chair, I took on the topology, service topology draft to try to get a rough area going. I am looking, Michael Wang and several other people have been helping me, but we've had to make several tries because this whole area of how a service layer sits on top of layer 3 is new work. So we've had several tries. Try one was, let's try a high level and then try to push the envelope by doing an SFC draft to link to the high model for ephemeral state. Well, we got lots of feedback from the FSC chairs that we didn't quite do it right. So the second try is what you see in the repository right now, where we're at a very high generic level, and we've got some general agreement in the last interim from IETF that this might be a good idea. Now, we're still looking for people who feel like they'd like to work on this. We're still trying to form a design team. The design teams we had made some good forward progress. We've taken it back to the working group, and then we need to keep going. So if you're interested in the service model, please let us know. Now I'm going to give a brief example of what this generic topology is, but I will start with the fact our discussion with the TEAS people last night showed we still had flaws. Now, the TEAS people are a full layer stack for TE, so they're thinking about some of this. Why don't you go ahead to the next slide? So this follows Alexander's methodology, and it's not in Jeff's recommended format, so I'll apologize right now. It may be an eye chart to read, but essentially we have a network topology, and what we've added is an ID and a count to make sure we know how many nodes are in a service topology. And nodes is the service layer look at the world. Okay, keep going. Thank you. Then you may have, that's on the network topologies. We then had the idea that you might have a service type. Maybe it's an L2 service node, maybe it's an L3 service node. You might have a Nextop, and you would have extensions for specific implementations for L2 or L3 VPN to add information. Go to the next slide. So then we have a link where you might have a metric. Go ahead. And then you have a termination point where you have an identifier for a network, a node, a TP. Now, some of this is where we have a question of, is this how you link a TP to an IP service node? So we'd look for more feedback. And that's it for our update for service topologies. We will be having interims to discuss this point so we can make more rapid progress, to report our rapid progress from the design team. And I want to thank all of the design team, Genghis, and all the other people that we've worked with to help us. Okay, that's it for the topologies. Are there any questions for the topology authors? Okay, we will go. Oh, good. One. Hi, Igor.
Hi, Igor Briskin, Ottawa. So Dan Bogdanovich, he actually had a very useful draft presented on NetConf, I believe, where he has like a description of classification of the various topologies and models. I'm sorry, various models and how they basically interconnect with each other, who uses whom, who is client, who's provider, stuff like that. So I suggested to add topology model as well to his classification, and I also suggest to add a service topology model. And if we would see basically not just layering and overlay and underlay, and also like a client-server relationship, that would be really great.
Igor, I had a little bit trouble hearing, so I will catch up with you afterwards to make sure I caught it all. Okay. Sam, you're up next, so you might as well come to the mic. That's okay. I get it. I should have had. There it is.
Hi, everyone. My name is Sami Boutros. I'm from Cisco. I'm going to be presenting this draft interface to packet switching element. We initially presented this draft in Toronto last year. Those are the list of authors. So interface to packet switching element is a collection of Yang data model that represents the routing table, the interface table, and the routing context that could associate those routing tables with interfaces or with MPLS labels or with VXLAN or VNI or whatever DMUX to identify those routing table, along with some of the interface as well configuration needed for what we call a packet switching element to perform the layer 2 VPN, EVPN, or layer 3 VPN functionality. So here we are talking about separating the control plane. So on the packet switching element, we are not going to be running the routing protocols, the BGP or the IGP or the MPLS control protocol. The packet switching element will be capable of resolving the routes or the prefixes that we are going to be setting up the routing table with via whatever next hubs that we are going to set up as well, the via in those routing table to go or to provide the connectivity. So this slide is simply presenting the motivation here is that we have a control plane that's not coupled with the packet switching element, but the packet switching element need what's the control plane. This is the BGP or the IGP routing information that they are going to be discovering over the network to be set up to that packet switching element. And of course, that's definitely in scope with what is being defined as SDN or software-defined networking. And here we are simply mentioning some of the advantages of that separation of the control plane out and how can we scale out the data plane or scale out the control planes this way. So, it's a reiteration of the point here. So what we are saying here, the packet switching element need the RIP or the routing table to perform, of course, the forwarding function or the data plane function to provide the connectivity. So he needs what's necessary for him in his position in the network to do that function. The IPSI, the way we are defining it, as we said, it's a collection of Yang data model for the routing table, the interface table, and the context table, or providing the relation to identify those routing table. So given that Yang data model, so we are saying it's a protocol agnostic here. As well, it's hardware agnostic because we are setting routing tables, so we are not tied to a given hardware or setting a specific data plane or a forwarding plane or a given hardware ASIC. We are setting our demarcation point here is at the routing table level. This is where we are setting the routing information. And we are using Yang as mentioned. So as mentioned, this is a collection of data model. We have identified the different modules that are needed, or this is the initial set of the modules that are needed to perform, again, for a given packet switching element, the layer 2 VPN, EVPN, or layer 3 VPN function. So those are the initial, what we define initially as the tables needed. So we are talking about interface table, context selector table, IP unicast table, layer 2 table, label table, and so on, including OEM as well. Those tables can serve not only for the provisioning of the routing table and the interface table, but as well for notification and so on. Next slide. So those are the main point again, once more reiterated. The motivation again is separating the control plane out. It can run out, not coupled with the packet switch, what we call a packet switching element. We are setting again on the packet switching element the layer 2, layer 3 routing table and the associated context with those routing table and the interface table to perform the function. On definitely the packet switching element, there will be a need of an agent that can receive that the data, define the Yang data model, and set up, of course, the packet switching element to perform the associated function. We are using Yang as modeling language here for the data needed by the packet switching element. We as well, given that control plane, we are perceiving that it can control more than one packet switching element, not only one, but set up again the packet switching element with the information needed based on its position on the network or on a given fabric. Then possibly the need of a faster encoding interface or a faster interface to set up those packet switching element may become needed. So this is why we are thinking as well about a binary protocol encoder that can be used here to speed up the setup of the routing table to the packet switching element. And that's about it. Any comments?
So Sammy, I have a couple questions for you. Anybody else at the mic? Happy to go first. So this work obviously shares some amount of overlap with things like OpenFlow or forces. Do you care to make any comment about what you think those might be and why you think this is better?
Okay, yeah, that's a good point. What we are saying here, our demarcation point for what we are setting for the packet switching element is much higher than an OpenFlow. So we are not talking about the controller or the control plane really resolving the full forwarding as an OpenFlow would require, right? So we are setting only the routing tables, right, with the prefix via the next hop, let's say, and then leaving the packet switching element the FIP function, which is resolving that prefix or route via and discovering the adjacency and doing that resolution that a FIP typically do. So this is why we are different than an OpenFlow function in that regard.
Okay. And the one other question I have to finish off my questions is IPSC intending to make use of ephemeral state, or are you intending to go for more of the standard netconf style static configuration?
Actually, we are open in that regard, right? So we are, accepting comments as well on that.
Okay. So the final bit of follow-up on that is obviously ephemeral state is one of our sticking items in the charter. If that's a thing that is something you're planning on building your infrastructure on that does cause you some level of dependency, one other thing I would ask you to consider is whether or not a RPC style mechanism, even if you're using Yang as your modeling language, is perhaps more appropriate for what you're looking for.
Mm-hmm.
And that takes me to the other thing is if you are interested in the IR2S form, have you done things like pub sub type work, or is that part of your plans?
You mean like an implementation?
Like an implementation, or do you have pre-implementation ideas on that?
Yeah, we are working on open sourcing as well, a given implementation on HC.
So just to make sure I understand, you're thinking of actually, for your code modules, putting in the additions for the pub sub requirements or the push requirements that we have.
I'm not sure I'm clear what you mean by pub sub here, right?
In IR2S, we have a notification mechanism that we've been calling publication subscription mechanism that we have a draft for. My question is whether your architecture and your plans had that in the architecture.
Sorry, I'm not familiar with that, but for sure we can look into that and see how can we leverage something like that.
Okay.
Real quick, Sammy. This is Eric. We can catch up offline.
Oh, okay.
On that.
Okay. Thanks, Eric.
So, and the same question with Joe and some of the traceabilities. We're interested to see, as this work continues, is it work inside the ephemeral state and some of the things that have been implemented, some of the things that we've been chartered to do in that regard. So we can catch up online, but I think lots of the authors here might like to ask you questions.
Okay, sure, thanks.
Hi, this is Henry Berger from Germany. On one of your last slides, mentioning of the primary
Correct.
Yeah, so just as a small comment on that, if you actually consider using a protocol, maybe using SQL, corresponding this font-size primary object representation, and corresponding data definition language.
Sure, can you please send that comment as well?
Yeah.
Okay, thank you.
And could Jeff and I get your name just so we...
Okay, sorry. This is Henry Berger from Germany.
Thank you. Hi, Bert.
Last slide, the binary database. Can you see that? Because you said in addition to NetCom, right? And RESTCom. So is that, so to speak, the northbound interface, or is that interface to the actual FIB?
It's the interface to the packet switching element, which is the actual FIB. Mm-hmm. Correct. Thank you.
Any other questions for Sam? Okay, then I think the next... Thank you very much, Sam.
Thank you.
And please sort of stand at the back of the room so some of the authors can find you at the end of the meeting. I'm next, so you get to... Gotta find it. Okay. Maybe I'll try the clicker on this if it doesn't work. Okay, I'm going to try a remote clicker. This is one of the requirements drafts that came in a little later. The chair sometimes gets to pick up requirements drafts when I don't find a volunteer. So this is about the protocol requirements that were initially in Jeff's requirements draft, but we split some of the stuff out into ephemeral state and network requirements. By the way, I really appreciate Jürgen's review. He got this draft and gave a review yesterday. He had editorial review, although 8, I may have misclassified, Jürgen. That may be real. I classified it in both ways because I wasn't sure if 8 was confusing or if it was just not a security requirement. So I put it in this slide in both, to be fair. I will go through the requirements, but I thought you could pause, and if you could just look at this for a moment. This is Jürgen's viewpoint, and Jürgen in the past had been our our NetConf advisor here, so you may want to take a moment to look at that. Notice his concerns is whether requirement 8 is a security requirement, and why is DDoS on a protocol a concern or requirement to NetConf, and why multiple messages was a requirement. By the way, I actually sort of pulled this from the requirement state and pulled it into the talking state. Andy, this is our, do all the errors, do part of the errors, stop on error section, and that's the multiple message. And then the last question that this working group really has to consider is early on in the working group we had the discussion that why support that we wanted to be able to have a transport protocol that wasn't encrypted or security based. And Jürgen is asking us one more time, is this really what you want? I will call for this on the list because I think his point is well taken, and we will have a debate on the last one. Go ahead, Andy.
Yeah, Jürgen pointed out you should ask the security ADs if they're going to approve that, because the answer is no. So the IETF is not going to standardize any non-secure transports for you.
I realize that. That's a really good comment, Andy. Thank you. Aaliyah makes a face, so maybe I don't know anything. But please, guys, I'm going to open this up on the list. And I will, of course, Andy, now check with Kathleen and Stephen and talk to Aaliyah, since it looks like I may not know everything about this subject as well as other things. Okay, I'm going to read through this and try to give you a talk. I'm going to sort of pause, hope that you can pull down the slides, but I'm not going to read all the pieces. I'm going to highlight certain security requirements. So the first thing we put in the security requirements is perhaps basic 101 on IR2S clients and IR2S agents with mutual authentication. I first thought if I said that, you understood all these points below, but I then, like a good requirements person, wrote them all out. So, you know, you must have at least one unique identifier. You must use these identifiers to do mutual authentication. The client must confirm the agent must confirm the client, and we agreed that we should load this on a protocol outside of IR2S. AAA and diameter or radius is a perfectly good way to transmit stuff. That may not be the way you send out your identities. You may do something perfectly valid outside of that. As long as it's secure, that's your thing. That's not what IR2S is about. In addition, there are three things which travel into the area of identity and secondary identity. Good, I'm still standing in the pink box. So IR2S should assume that the distributing or the loading of these entities will have to be before establishing the connection, and that includes both the primary identity and second identity, and the identity must be linked to one primary. The link with a secondary identity only is required to be the same during a particular read or write sequence, but it may change. And again, this is the opaque value that allows different functions within a single client identity to change. Had a lot of debate on secondary identity. With the NetComp meeting on Thursday, this may come up, so if you're interested in this topic, I encourage you to be to the NetComp meeting. What time is the NetComp meeting? 1 to 3, I think. Pardon?
1 p.m.
Thank you. 1 p.m. on Thursday. IR2S is immediately after it. Please come. The transport requirements, we should use a secure transport. Jurgen said, so why would someone do something else? And I understand that comment. That's actually a good comment, but we did go through and say, this is what secure transport means to us. We will be able to support the transfer of data over secure transport. Here is where we have a non-secure. Aaliyah, did I do something wrong?
No, I was individual.
Please go ahead.
Sure, Aaliyah. So the point of the non-secure transport is not for push to state into a device, right? The point of it is to connect it to the pub sub type thing. So you can say, here, think about this. Suppose they have a gang model, they want to say, I IR2S created a model and say, please send me this data to this address using IR2S. And for configuration piece, setting it up, making sure that it's going to an address that you're allowed to configure. Of course, that part has to be over secure transport. But the delivery of this information probably isn't coming over secure transport anywhere with us today. That's the type of non-secure transport type of thing. If there are parts of the model where it makes sense to allow them to be read in a secure fashion, that's a possibility. By requiring only a secure transport for all information that are out, we end up creating a fair amount of bottlenecks. That's the kind of point. It's for the pub sub stuff.
Thank you, Aaliyah. Jurgen?
Jürgen Schneider, Aliyah, don't look at me. Look into the face of security ADs. I believe they have a very different view on what it means to push something over the network which is not encrypted.
Not all of so information has different value, not everything is confidential. That's where we said information today is not encrypted, that is state magnetic information. Obviously, we're going security, but I do want to, this is not configuration, we're of course we need secure authentication for exact identification for all the reasons that we usually have it for that time. This is for things like
Please go ahead.
Wes Hardiker. I don't think that, I mean, you're really talking about two different transports here, right? You're talking about how to configure the pub sub over something else. Well, that configuration mechanism certainly needs to be authenticated, and netconf provides that. That's really, so this requirement really needs to have two pieces. One is how to do the configuration and how to look at the configuration. That's going to require the security properties. If IPFix doesn't go over, anything secure today, well, maybe it's going out over, HTTP doesn't go out, isn't secure today, but people still use it. That's just fine in some cases. But from a netconf point of view, the chances of opening up a netconf protocol, which, exposes a whole ton of configuration over something that isn't, authenticated and hopefully encrypted probably won't fly. But I think that's okay for what you're trying to do.
Yeah, and what I suggested as a solution is, as we talked about transport independence, you can say, here, we're using that composition. When you deliver this information, deliver to you this transport, where that transport might be SCTP, it might be FIX, it might be pick your favorite transport fleet. But the point is, we want to be able to deliver notification from the part of the device that has the information, because we care about timeliness of the stuff, without imposing overheads on all the different pieces of layers, whether it's UDP and TCP, and so on.
Kent Watson, Juniper Networks. Just regarding the sensitivity of the data in the netconf notifications or the notification messages, they may contain XPaths to the data node that was modified, and just that alone is already revealing, maybe to a point of being a concern.
Yes, so who wants to do it, but in the architecture we talk about read scope, write scope, and notification scope. So if you request to get notification false anonymous for transport, sometimes depending on what your configuration is going to be,
Any other comments on this? This is exactly the type of discussion I was hoping to have. Thank you, Aliyah, for helping me out on this. Is there any other question on the non-secure section of 9? Okay. Another one that I don't know if I worded correctly is the secure requirement 10. It must be associated with a key management system. Now, there are many key management systems. We did mean that pre-shared keys were acceptable. And if anybody who is a key management person will look at the requirement text and help me fix it, I would appreciate it. Jürgen says I'm not quite tight enough. So please make comments, send me any text corrections there. Okay, the next thing is IR2S must be able to support multiple secure transport sections, providing the protocol and data communication. So I think we've just gone through that, but we've always said you must be able to have more than just one. You must be able to have 4 or 5 parallel ones. And that's really an important piece. And IR2S, this is where the DOS mitigation one was. When we had a security person who spends his life working on security. Daniel, are you here from Ericsson? If you are, will you raise your hand? I sure hope he's here. I don't want to give his slides. I'm not a security expert, but Daniel spends his life. Joel, is Daniel here? Or are you giving Daniel's slides? Okay. Do you want to comment on this DDoS stuff for Daniel? Okay. So Daniel, when he read through all of our security and he walked through it, he actually spends his life working on Ericsson devices and security, and he's in the security section. And this is the one he said, you need to make sure that it has DDoS protection. Any normal security piece does. So I added it, and I'm going to go talk to the security director and get Daniel and them talking to find out why he felt it was the one critical piece to add. So if we find something good, Jürgen, from the security people, I will put some more detail on this. If we can't find substantial, we'll try to pick it up. But that's where I got that one. In a critical infrastructure, this is just that it has to be confidential. And I think I haven't had very many comments on this one. This is an integrity that it shouldn't be modified without detection, that it's actually coming where it's supposed to come from, and it's not repeated. Man-in-the-middle attacks are what some people link this to. Number 15, the integrity not repeated means that the transport should protect against replay attack. We all know that's important. And last of all, the traceability that we've already got in another requirement is important, and it should be supported. This is, again, in a channel that is non-secure to trace about security issues. We'll go through this one to see if we can work on the non-secure section as well. Again, if you're a security person in IR2S, we would really like your review, but that is something that if I read your comments earlier, Jürgen, we should probably include this in the non-secure section. And I believe this is 17. Andy, you will now recognize perform until all is done, perform until error, perform until. I took that out as a requirement. You know, we had discussions on it, and I don't want to put it as a requirement till we have a bit more of discussions. I need to churn this and make sure that because it was in the architecture, we understand it, but based on our comment, I thought that really needs to go away from the specific requirements till NetConf and IR2S talk a bit more. Same thing, another man-in-the-middle attack. Role security must be used, and IR2S clients may be used by multiple applications, and you need to be able to turn on the audit stream or turn on the traceability. And I think we considered in the audit stream that the traceability was the appropriate level for most audits. If you think the audit stream should be deeper, please let us know so we can work through some of the requirements. That is the end of my piece. Thank you for the great discussion. Thank you again, Jürgen, for your review. I hope to improve the document. We will finish this week out and then try to go for a working group adoption call. Every time I adopt a security document, I will probably work on it a bit longer before we consider it finalized because, repeat, I am not a security expert. Okay, Joel, it is your turn, and that is our last presentation before the social.
One final check. Anybody who has not signed the blue sheet?
While Sue is setting up the slides, I'm Joel Halpern with Ericsson. I worked with Daniel and Sue on this. It started with Daniel coming to me and saying he was doing a security review because he's really an expert on this stuff, and I then started working with him on what assumptions we as a community have been making about the system, because sometimes it's hard to get from the words we write to what we mean. So then he tried to capture the security, and then we reviewed it with Sue, and she pointed out really there were two categories of things he was talking about. Stuff that was intrinsic, which were mostly in her existing document, and stuff which were about the surrounding environment. Now, how we will position this document, whether it becomes informational or whatever, is not obvious. It's probably informational. It's documentation that writes down what we have assumed the environment is going to do so that the security things we say work will actually work. That's what we're driving at here. So we make a lot of assumptions. We don't always spell them out. For example, we say I2RS agents are assumed to be co-located. course, that can be more complicated. And that clients may be co-located with applications or providing services. These are things we assume. So, similarly, there are security assumptions, and we're even worse about writing those down than other kinds. So, the current doc doesn't describe them well. So we're trying to capture that. That's the focus here. And I'm not going to go through everything in the document. The document is careful. It says, here we're going to describe what the question is and then what we think the requirement is on the environment that is required to meet that. Because we had an interest, one of the observations was some folks like to state requirements and then explain them, and some folks like to state context and then provide requirements. And the only thing that's really bad is to do both in different places. So the document picks one approach and tells you which way it's doing it. So we group the requirements into three kinds of requirements: plain isolation requirements, AAA policy requirements, and application isolation requirements. And they're pretty straightforward. And again, I say the details are in the doc. This section treats the I2RS exchanges as a separate plane from the data plane, control plane, the management plane. I don't care whether you want to treat it for all purposes as a separate plane, whether you want to treat it as part of the control and management plane because you think they're really one plane. An awful lot of the SDN stuff munges control planes and management planes, and drawing hard lines is tricky. What we're saying is the set of behaviors I2RS is discussing can be considered a plane for the purposes of this discussion. Whether that's the right way to model it for explaining I2RS is a whole different question. So the point is that this exchange, because of its nature, we are assuming has isolation and security characteristics. That the connectivity mechanism, whether that is a separate authenticated tunnel, IPsec, or whether it is physical segregation, because many operators want this kind of thing to be on a physically separate network or different VLANs, but attention needs to be paid to that segregation. So what we tried to do is point out there's a general isolation issue and a range of techniques. And then there may be cases where the I2RS plane needs to interact with the other planes. After all, a plane that doesn't affect anything else is not really very important to your work. So we try to cover this material. I'm probably talking too fast, but AAA. We depend very heavily for the reliability of what we're doing, the security of what we're doing in I2RS on AAA. And of course, we can't mandate you shall use radius and you shall do this request and that request. A lot of different ways to deploy AAA. A lot of different ways to store the information in different systems depending on how you run your network. But we do make assumptions about the capabilities. So we have a whole section that walks through the kinds of assumptions we make, the information we are assuming the AAA provides. It doesn't care whether it's diameter, radius, TACAX plus, I don't care which protocol it is, but you've got something that's giving you this information, and you're making assumptions about the reliability of that. There probably is actually more that needs to be said about the security model of that we are taking for granted. I haven't re-reviewed it since I thought of that question. But the point is to clarify what we're assuming about AAA and make sure it's spelled out so that folks trying to use the I2RS work know what it takes to actually meet the security we're claiming to get. And we have all sorts of discussion in the document about direct collision and application interaction, but we don't really spell it out from the point of view of the applications, from the environmental point of view. And among other things, this gets back to DOS effects. You don't want one application's activities denying service to another application or the underlying network. We've tried to define things like the collision mechanism to at least reduce the likelihood of this. But there are things you have to do deploying your applications paying attention to this. Don't write and deploy applications that every time they get an error that says your state went away, will promptly turn around and try to reapply it. Because one of two things will happen. Either it will win, and then the other guy will do the same thing, and you're going to bounce, which is really bad. Or they'll fail, but keep trying, which is essentially a lot of waste. So these are things you need to think about from the application perspective based on what we're doing in I2RS. Again, we're not trying to change the I2RS behaviors here, but point out the behavioral assumptions that underlie what we've done here. And that's all I have to say, because I'm not going to run through it section by section. But if there are questions about the approach, I can tag them. Questions on details probably should go to the list, because Daniel's really much better at why exactly did you use these words to describe it? I need Daniel's help, and he's over in the DOS session, dots, that's going on in parallel with this. Any questions? Seeing none, my thanks to the chairs.
Thank you very much. We will, please send your questions to Daniel on the list. This is the end of our presentations. We thank you for your time. Recall that we will meet again 1 o'clock for the NetConf session on Thursday. I ask all document authors in I2RS to attend the NetConf session in case people have questions. I also will ask, we will have a discussion there, and then we will continue on with discussions at the I2RS meeting on Thursday. Thank you again for your attendance.
This is the first one. Non, tu sors, Jean-Marc. I come from